Good morning, everyone. Thank you for being here on Republic Day. We are very happy to have all the kids and the educators and Daniel join us from Canada this evening for him. So I'm Supriya Bhualka. I'm an educator and founder of Coding and More. We are a personalized edtech that teaches AI and coding to children. My team of educators and I are invested in having children learn the different applications of AI in various fields. With COVID having been with us for the past 2 years and counting, people look at the bleak side. I believe we should look at the positive impact that COVID has had, with nothing really stopping, with school going on, work going on, connections being made across the world. I would not have met Daniel if it wasn't for COVID. Um, this pandemic has been expedited because of the use of technology, which is why we have invited Daniel here from Canada to share with us how he used the use of technology in order to help researchers and scientists and volunteers across the world. Daniel is not an AI expert, but he is a lifelong learner. He wants to learn, he wants to make a difference. He's actually an VR expert at Banging Rocks, and he is a mentor at the University of British Columbia for emerging media. But I think he also volunteered his time at a nonprofit called CoronaWhy. So I'm going to pass it over to Daniel so that he can explain to us what exactly he does, and how did they use technology in the time of COVID-19. Kids, whoever was in there earlier, if you all have questions, please put it in the chat. Daniel will definitely try and answer all your questions. Don't be afraid. Nothing is a stupid question. Over to you, Daniel, and thank you so much.
Thank you so much for this opportunity. It's really neat to get a chance to talk to you all. So I'll start with just a little bit about who am I? Why am I talking to you anyways? So I'm Daniel Lindenberger. And as Supriya mentioned, I'm the Emerging Media Mentor at the University of British Columbia's Emerging Media Lab, where we work with faculty and with students to come up with innovative approaches to learning that involve sometimes artificial intelligence, virtual reality, augmented reality, a whole range of different tools. I worked at CoronaWhy, which I'll talk a little bit more about soon, mainly with internal and external communications, and a little on unmanagement, which was how we ran things there. It was a self-organizing system, and it was pretty neat. I'm founder at a company called Banging Rocks, where we do virtual reality for positive impact, and that ranges from doing things in the arts, doing things with meditation, all sorts of different things we do there. And I'm co-founder at Thomazo, which is a forming charity. It's just in forming right now, that's focused on bringing people together for the United Nations Sustainable Development Goals. And as Supriya said, I'm not an AI expert. I work with AI experts, and I know a little bit about it. But there's probably going to be a lot of good questions that you have that I hope that you ask that I may have to answer. I don't know, and we'll figure out together where we would go and look for the information. So a couple of good starting points. I'll also mention, please do feel free to throw any questions in the chat. If something comes to mind, feel free to just to shout it out. Although, of course, that can be a little challenging with the way that the connections in Zoom work, but do feel free. I want to start by saying AI isn't just one thing. As those of you who've been starting to explore it know, it's a whole range of different tools. What we even consider to be artificial intelligence changes a fair bit from time to time. Things that in the past were considered artificial intelligence are just considered basic programming now. And new things, new ambitions around how it can be used come up and start to be things that are studied. Artificial intelligence isn't a magic bullet. You can't simply release the artificial intelligences and have them solve things for you. It's a tool set, and you have to figure out which are the right sets of tools to use for the given task that you have. And then you have to apply them in the way that you need to get the results. We'll give it one good example of that as we talk further. At CoronaWhy, we had a very heavy use of a type of artificial intelligence called natural language processing, and I'll talk a bit more soon about why that was. But so that shapes a lot of what we're going to talk about here, and is a very exciting area of artificial intelligence.
Different one thing.
First, a little bit of that background. So the White House back in 2019 requested that a collection be made of as many articles as possible, as many scientific articles and research that was being done on COVID-19, so that researchers would have access to them. It started with about 24,000 articles. Now it's about 280,000. I'm just going to post a couple of links here. So this first link is to a couple of those organizations that I mentioned. This second one, if you're interested in this COVID-19 data set, which is again 280,000 different articles all about COVID-19 from researchers, you can access those articles there. This huge data set was made, and the other player that I'll mention at this point is Kaggle. So Kaggle is a really interesting group. They're a machine learning community, and they host competitions. If any of you haven't had a chance to check out Kaggle and are really interested in AI, I'll post a link here, and I would recommend you check them out. They offer no setup, customizable notebooks in environments where you can explore and experiment and build off of what other people have done as well. You can access free GPUs, and so even if you don't have a very heavy-duty computer, you're able to use their computers in order to do some of that heavier processing. So Kaggle, as I said, hosts competitions within that community, and they, together with the Allen Institute for Artificial Intelligence and a few others, took this COVID-19 data and put a challenge together saying, who can best help answer, using artificial intelligence and machine learning, key questions about COVID? This led to the formation of CoronaWhy. So CoronaWhy, and I'll just give a little link there. Let me also give a link to Kaggle's competition in case anyone wants to look into the details around that. So CoronaWhy was founded by an innovator and an artificial intelligence expert, Arthur Kulian. And he, even though the competition was only supposed to have a few people on each team, he said, let's not care about that. Let's not care about winning. Let's get as many people around the world who want to help make things better with COVID-19 together as possible. And within a few days, it went from a handful of people to hundreds of people. Eventually, it was over 1,000 people, or around 1,000 people, in about 23 time zones. So in almost every time zone that exists, there were people who were participating, ranging from high school students in India to experts in advanced projects at NASA, all working together and collaborating in a self-organizing way. And it was a community that was all driven by different projects that were going on. So here's a bit of this is a snapshot that was taken of how the community was spread out at one point. You'll notice that right behind the United States, India had the most participants. That actually, I think that essentially if you added up all of the other participants there, that India would outweigh all of them. So, so the fact that there's so many people here who are interested in learning about AI and working with machine learning is no surprise to me. When working with artificial intelligence, one of the key things to do is you start with a goal, or you start with a question, so you know which tools you want to be working with. At CoronaWhy, based off of the data that we had, the articles we were working with, the questions we settled on as a group, we voted on them, were 4 key questions. The first was around transmission and incubation. We wanted to know as much as we could about how COVID was transmitted and about incubation periods for it. I'm going to put in a few links here right now, and these are the links to as much information as you would ever want to know about how CoronaWhy worked on each of these different topics. So here's the link for transmission and incubation. The next topic that we were looking at was risk factors. What are the different things that make it more easy or less easy to catch COVID? And there's the link for that. Next, we were looking at vaccines and therapies. Now, and this was back right in early 2020. So this was before there were any known vaccines, before there were any known therapies. So we were looking at what might be the possible compounds and substances that might function as a good therapy, and what approaches to vaccines might be useful. The next was around how did geography play into things? What were the geographical factors that contributed? And that team worked with the other teams to see how it related to the work that they were doing. For what we're going to talk about today, we're going to dive more deeply into transmission and incubation. So how does it get passed along? And once somebody has COVID, how long does it incubate for? What does that look like? Lots of different questions with that. Actually, here, let's talk about the questions there. One is around how long does it take? What are the shortest and longest and average time that it takes for someone to go from getting the virus to being able to give other people the virus and being able to have symptoms that let you know that they have the virus? How common is it for people who have the virus but who show no symptoms to shed and to be able to transmit it to other people? When I say shed, what that means is that they're putting that virus out into the world. What's the persistence of the virus on different surfaces? If I have COVID and I touch glass or I touch wet cardboard, which surface is it going to stay on longer, and by how much? Movement control strategies and how well they work. If some areas were having people stay in their houses, how effective was that at preventing the spread? If gatherings of people in groups of more than 10 wasn't allowed, what effect would that have? So what were the different strategies and how well did they work? And how well did different kinds of personal protective equipment, gloves, masks, anything like that, how effective was that at working to prevent COVID? So knowing that those were the questions and knowing that we were working with this vast set of articles, I'll talk a little bit about the approach that that team chose to use. Some of the terms that are in this description may be familiar, some may be not familiar at all. Don't worry about it. We're going to dive in and we're going to talk about them in a little bit of detail. So the first step is designing queries for each of those different questions of interest, figuring out what are the key words, what are the things that you want to break down that knowledge into. So things like which type of disease is this? What are the different variants of COVID that we might be interested in? Before COVID-19, there was other useful research going on COVID generally. What populations are we interested in? Definitely the human population. Some articles were about cats, for example, and we wanted to exclude those ones most of the time. Also, any other breakdowns? So were we interested in certain ages? What about health status and setting and the outcome that people had? If they did catch COVID, what was the outcome for them? All of these things, trying to encode those into good sets of keywords that could then be used. Next thing that we did was take those sets of keywords and run them sequentially, one set by one set, through all of those different articles using something called BM25. And what that really is it's a bag of words. What that means is each article's abstract, which is like the opening paragraph that tells you what that article is going to talk about. It would take it, slice all of the words up. We don't care about the order of the words. We don't care about the grammar or anything like that, but we do care about what words show up in the article and how often do those words show up. An article that has the words incubation and COVID in it, a whole bunch, is more likely to be something that's going to have something to tell us about the incubation period of COVID. So this is a specific way of doing those kind of bag of words searches. Once that was done, and so some specific articles were identified as probably being the most likely to be relevant, then what's happened is train a topic model, and we'll talk more about that in a second, on all of those different abstracts. And then you use that model to find which are the articles that seem most relevant out of all of those different ones in a more sophisticated way. So let's talk about that for a second. You'll see it says the word SciBert there, so we'll talk a bit about what that means.
Excuse me.
Yes, please.
I don't know, but I think it's going a bit fast. Could you slow down and explain us the parts, because I didn't understand the previous model that you showed us on the previous slide.
Yes, thank you so much for letting me know. I really appreciate you letting me know that I was going a bit too fast. So a good example of a bag of words search that you might have seen is a word cloud. If you've ever seen pictures that are made of words where the words that appear most often in something appear bigger and other words are smaller, that would be an example of a bag of words. So the way a bag of words search works, the simplest bag of words search you might do is simply you count how many times does every word that's in the article show up, and then you can list them in order of frequency. The next thing you might do is say, well, I don't really care about words like to and the. So you tell it to remove some of those words from what's being searched for. And you'll get something that's closer to the amount you want. There's a bunch of different strategies to refine those bag of word searches. But the key thing with bag of word searches is you're not caring about the syntax or the meaning of the sentences. It's just about counting words and different ways to do that. Does that answer the question around that part?
Yeah. So you're talking about how they use
like
this.
a word splash.
Yeah, so they use this to research into the incubation and the transmission on the articles, right?
100% right. So first you come up with what are the words that we want to be searching for anyways, and then you do an initial search, and this is kind of, it's like a naive search. It's a very simple search to do, and it pulls up a bunch of the texts that it thinks are most likely to be relevant. And then in this next section, what we're doing is we're getting more sophisticated, and this is where the artificial intelligence really comes in to refine that search and say, you know, of these bunch of texts that might have to do with, say, transmission, here's the subset of those that almost definitely do and that are talking about the topics we're interested in. So then this next part will be us talking about how that happens. So I mentioned SciBert. Let's break that down into what that actually means. First, it's a type of neural network. So with a neural network, what it is really it's a bunch of different nodes, and you have a set of input nodes that you can feed whatever type of data you want to. You then have one or more layers in between those input nodes and some output nodes. It's trying to model the way that our neurons work in the brain, even if sometimes a little bit naively. But it's a very effective tool for pattern recognition. And so you can train these neural networks, and by different ways of training them, they can get really good at noticing patterns. And that can be used both for the two key areas, or two of the key areas for that are categorization. So for example, any program you've ever seen where it can recognize someone's face, or it can even recognize that something is a face, or if it's able to read handwriting, those are all neural networks that are doing pattern recognition to categorize some of those different things. The other things that it's really useful for sometimes is prediction. As it recognizes those patterns, it can begin to predict what may be next in a certain sequence. So neural networks are wonderful for pattern recognition. A type of neural network is a transformer. Transformers look at sentences and they learn how words relate to one another. So they're good at figuring out if certain words are in proximity to each other, if they're close to each other, then here's some of the other words that are likely to be close. One way that that's done for training and where it can be useful is masked language modeling. So if I say to be or blank to be, most of you would probably be able to come up with some word that's going to be pretty plausible as the word that should be there. Teaching a machine how to do that, that's something that the transformer is really good at doing. I'm actually just going to post a couple of neat things here. So right here is a link. It's a big link, but if you click on that one, it gives a really neat interactive way to explore neural networks so that you can kind of see a little bit about how they work. I'm also going to post when I talk about...
Why you are sending these links?
Oh, these are so that you can explore these. If you cut and paste these links, then you can later on go and you can check out these links so that you can experiment with the different things that are there or find out more about some of the things we're talking about. And I'll make sure that Supriya gets all of these links as well, so that if you don't get them right now, you can get them later on. One other link I'll post here is for a really neat way of exploring transformers. So when we talk about how a transformer can be used also to predict what words are going to come next, this is a really cool link. If you go to that link and you type a little phrase, any phrase
Hi,
you
Daniel.
want.
Hi. So is this what is used in predictive text, like even when we're writing, Gmails or even regular texting?
Fantastic question. Yes, transformers are absolutely used for that. Even when you go to Google and you begin to type a search query and it then offers suggestions of what you might be searching for, there's a transformer behind that that is making those predictions of what it might be that you're looking for. In fact, transformers and the parts we're going to be talking about next have been developed a lot by Google. Yes, go ahead.
are you trying to say on WhatsApp or some apps, on iPad or your phone, those options come at the top when you write a word wrong or something?
Oh, well, those are a different type often of artificial intelligence for when it's a single word that you've written wrong. But similar to that, when you use WhatsApp or you're using a messaging platform and you type some words and then it tries to suggest what it thinks the next word might be, that would be something that a transformer is probably doing. Great question.
Yeah, thank you.
So that's what transformers are really great at. They figure out how do words relate to each other and which words probably are going to be close to or come after a given word. A special kind of a transformer is BERT, and not surprisingly, because they have a lot of interest in language, Google have really pioneered, they invented or certainly have honed BERT. They really kind of came up with it. And the fancy way it says it is bidirectional encoder representations for transformers. We've talked about what transformers are. Bidirectional just means that sometimes the clues about what a word means are before in the sentence and sometimes they're after. If I say the wet river bank, you know what kind of bank I'm talking about, and it's because of what came before. If I say the Bank of Baroda is closed on holidays, you also know what kind of bank I'm talking about, and it's because of the words that come afterwards. And so BERT is able to use both of those kinds of clues to figure out what's most likely to be the meaning of, or not the meaning, but which words are probably related to each other most. And the folks then at Google took all of the text on Wikipedia from every article and said, these are pretty good examples of how people write. So we're going to feed all of that into this transformer so that it has a really good understanding of how words relate to one another. And so BERT is a tool that any of you who are interested in are able to use. Here is the link to the code for BERT online. So training it on all of Wikipedia gives it a certain type of use. SciBert is just a version that's more specifically trained on scientific data. And so it's going to do a better job of understanding that when the words incubation and transmission are there, period might be a word that's going to be close by. And that those words are going to be related to one another. So SciBert is able to work much better with scientific articles, which is what we were working with at CoronaWhy. And so that's why that was important. Jumping from there, actually, before I jump to there, I'll just say, any questions on any of those 4 parts? If not, I'll jump back from there now quickly to this. So using these SciBert models that have a better understanding of those topics, we use those to figure out which of those articles are really most likely to be the ones that are most relevant. Here's an example of some of the results from that. So the light pink that you see there are the number of articles that Bag of Words found to relate to a given topic. The number of articles that do, and the darker pink are the number of ones that SciBert was able to find that related to it. So, you might have 200 articles that get found by Bag of Words and an additional 50, which SciBert picks up on, where it's not the frequency of the words, but how they were linked together that made SciBert decide, oh, okay, this is probably also talking about the topic that we're looking for. Once that's been done,
excuse me.
Oh yeah, go ahead.
I'm sorry to interrupt, but what's the full form of BERT?
Could you say that again? What's the full form of BERT?
Yeah.
It's bidirectional encoder representations for transformers. And again, bidirectional just means it goes both directions in the sentence. The encoder is the part that is taking the sentence and encoding it in. And it's encoder representations because they fed a whole bunch of data in to build those representations. And transformers are what that's aimed at. Good question.
So, yeah, yes, I had a question.
Yeah, please.
Yeah, so how do you make the transformers? How do you make these transformers?
Yeah, great question. So if you go to that link that I put, the 6b-eluther.ai link, you're going to find out loads of information there about how transformers work. And I think that it will also take you to GitHub repository where you can see the details of how they've made it. If you search up AI transformer, you'll find a whole bunch of really great articles that go into a lot of detail around how transformers work in specific. It's always tricky because, you know, we only have limited time and I only have limited understanding. And so being able to go to the right level of depth around each of these different parts.
So basically, the transformers are not physical devices, right? They're already pre-installed and pre-trained AI features on devices.
Yeah, so you're right that it's not a hardware piece, and a transformer undergoes training. And so typically when you're using a transformer, it will be something that is pre-trained. You could always train one up from scratch, which could be especially useful if you had a really specific goal for what you were doing for it. But typically, and actually I'm really glad you asked this question, typically they're pre-trained and then you further train them to help them understand and kind of point towards what your specific use for them is.
Okay.
So once the relevant articles are collected, then one of the tricky parts is trying to pull out the details, like what were the age of the participants in this study? How was it designed? Where was this study taken? Where did it take place? And a range of other machine learning and NLP techniques are used within that. Let me just see here. I'm going to post the link for SciBert. And again, natural language processing is just such a huge area that it's
Sir,
yes,
excuse me,
please.
sir. Sir, that link is not opening to my
Oh,
side.
oh, okay. We can do some troubleshooting afterwards. Thank you. Someone asked what geolocation means. That just means things like where in the world was the study. So, oh, this is a study that's coming out of Turkey, or this is a study from South Africa, and it might go into more detail. So for some of the studies, there might be data we were looking at where it would give the individual locations of different people who were, say, infected with COVID. So geolocation is just where in the world is that.
Yeah, so I had a question. What's the full form of ML and NLP?
You say what's the first form?
Yeah, what's the full form of ML and NLP?
The first form of it? Oh, that's such a good question. Like, what was the original version of it that was created? Oh, no, just what does it mean? Yeah, ML is machine learning. And NLP is natural language processing.
Okay, thank you.
Yeah, no, good question. Thanks, Shivam.
Excuse me, sir.
Oh, my mistake. Thank you. And then the final step that was being taken by this group was then analyzing and then visualizing some of those things that were found from the articles. So a couple of examples. A researcher would be able to go to the tool that was made. And again, it was a demo. It was a proof of concept, not a fully fledged tool at the stage that it was turned into Kaggle. That they could look and see when were articles written about the rate of incubation, or the range of incubation periods, how long it took for people to actually show that they were sick. And you can see from 1995 up to 2020, for COVID viruses generally, here's the frequency that those articles came out. This tool could then be made so someone could click on any given one of those dots to see that article. Another great example would be pulling out the data, and this is a good example of where AI comes to the fore. For range of incubation periods, you'll see that someone has made this, or rather the machine has made statistical models so that it can say, based off of the age of the person.
Sir?
Go ahead.
Sir, I can't understand the upper one slide.
Sorry, say again, you can't understand this slide?
No, sir, the upper one.
This slide here?
Yes, sir.
So the basic thing for it is that it's showing statistics. So things like what's the average incubation period, and it's trying to show how that varies over age. So for each of these, the key thing that I want to get across is that the machine learning is able to pull out from all those articles and say, here's what we know about the range of incubation periods, let's say. So it's going from just having words to really having sort of some detailed understanding. Thanks, Agrima, for a good question. Incubation is the amount of time between a virus, in terms of virology, it's the amount of time between a virus getting inside you and the time that you actually sort of have the virus, and that you are showing symptoms or are producing and putting that virus out into the world. So yeah, thank you. That's a great question. So each team had its own approach. We just went through the specific AI approach that was being used for transmission and incubation. But if you follow those different links for each of the different groups, you can see in detail what the approaches were for each. And again, if you follow those links, there's interactive things you do based off of what each of those different teams did. I'll talk just quickly about some of the other areas outside of what we were working on, where AI comes in handy in terms of COVID. One is primary research. There is a group that's been using neural networks again to screen potentially useful compounds as antivirals. What that means is that they can look through millions of different chemical compounds, and before the researchers begin to do the really detailed work to figure out which of these might really be something they could use, the computer can go through, and with neural networks, it can go from these several million different potential compounds, and it can pull out the ones that are the first ones that the researchers should look at, that are most promising from that AI's point of view. So it helps take a process that might take years and turn it into something that might take months instead, or in some cases it can take less time than that, weeks. Prioritizing and understanding the research results is what we were working on. We were working on figuring out how to take all this information and help other researchers find the parts that were most relevant to what it was that they were working on. Logistics is another really useful part. So every hospital has a certain number of beds and a certain number of intensive care beds, and they need to figure out how to allocate those. They need to know, this week we're going to block off these rooms for potential use by people with COVID. So again, neural networks, because they're so good at pattern recognition, are being used to do some prediction around that. And if I remember right, they were working at about a 95% accuracy at being able to help hospitals know, here's how many beds you should be reserving for, say, the next week or the next month that you'll probably need for COVID-related things. So those are just a couple of the ways. We've talked a little bit about what you can do with AI there. I'd love to hear your questions, your ideas around how AI could be applied to COVID or to other things that you're passionate about, whatever you're interested in. What are some areas where you could see artificial intelligence applying?
Sir, what is the meaning of AI?
AI is artificial intelligence. And a lot of the people who really are engaged in working with it prefer the term machine learning, just because there's so many big images that come to mind for people when they think artificial intelligence. People picture, Terminator or things like that. And so machine learning doesn't have quite as many ideas that might be mistaken that are attached to it.
Daniel, Raha and Karma had a question. She didn't actually follow, how you use BERT for the research papers.
Yeah, no, so thanks. Sorry that I missed that, Raha. So the key thing there is because BERT is able to figure out how words relate to one another. And what we had to work with was 25,000 articles all about research for COVID. BERT was able to pull together the words that we gave it. So as an example, let's say we were talking about the range of incubation periods, or actually let's choose persistence of the virus on surfaces. You could tell the computer, let's look for the words virus, let's look for the words persistence and surface, let's look for the word duration, let's look for the word active, and the whole team spent quite a lot of time brainstorming, trying different word combinations and seeing what the results that came back from that were like. So it's definitely something where there's a lot of refining back and forth to actually start to get results that are meaningful and to make them as good as possible. But then what BERT does is, because it's helping build those associations and it has a better understanding than just counting the words, it does a better job of saying this article over here, you know, it only had the words glass, surface, active, and period. It didn't even mention the word persistence or virus, but because it had those words in this way, and because of the scientific literature that I've been trained on as SciBert, I think this probably is an article that's going to be important. Does that make sense? Oh yeah, full form of BERT again. Let's jump back to there. It's bidirectional encoder representations for transformers. Any things like this, again, we'll make sure that we send more resources. Any questions you have, I think, you know, Supriya and I can brainstorm and make sure that we get you some good resources to understand how any of these things work, or at least to dive into them. Thanks for asking again. Yeah.
Hi, sir. So I am a fan of cricket, and I can actually see AI in cricket as a recommendation, because based on what you are clicking on, like what scores you are clicking on, it will basically recommend more of those matches, or the team which is playing those matches, that team's matches, or that player's matches, or those stats for you. So I can see AI in cricket.
I love that. I think that's brilliant. I think you could do some amazing things with AI and cricket. And who knows, you might pioneer some things on that have an impact on how people think about it or watch it or learn about it. You know, it was a little while ago, it was many years ago now, I guess, that people started to apply that kind of thing to baseball. And before that, when people were picking, like, who do we want on our team for baseball? They had a very simple way of doing it before, where they'd say like, oh, well, I went and I saw the people and that person throws really hard, so we'll pick them. And then later they started to apply artificial intelligence essentially to it, to make more predictive models, to say, this person isn't great right now, but everything about how they're playing says that probably 5 years from now, they're going to be really good. So let's sign them on to our team. So maybe you'll be the person, Vardhan, who does that for cricket. I see another question from Siobhan. What does BERT represent? What does the meaning of its full form? I'm just going to type it in here, just because that's a popular question. So it is bidirectional encoder representations for transformers. And again, if you want, we can go through the details of what each of those parts means. Bidirectional is because it's not just reading left to right, it's taking the whole sentence in. In transformers, there's an encoder and a decoder component, and this is about how you do the encoding. Representations is that it has been trained on all of this information. I might be wrong about that being the reason why it's called representations. And so there's other experts who I might rely on to correct me if I'm wrong about that part. And it's for transformers. So BERT is a type of transformer, or is a type of representations for those transformers. So that's why it's called what it is. Yeah, any other questions or comments or ideas?
Daniel, I also wanted you to touch upon to the children what we spoke about earlier, that even if you don't know about a topic, you know, it's never too early to start, right? And you want to go forward, you know, what we spoke about?
Yeah, absolutely. And one of the things that I felt really lucky in my life around is that I've always just had the instinct to, when there's something that I'm fascinated by, I find whoever I think is the coolest person who knows about that thing, and I try to ask them about it. And one of the things that I learned from that is that most often the people who really know their stuff around a given topic, as long as you're willing to do enough of the work to show that you're serious about it, they love to talk to you about it. And so you might be 10 years old and keen on BERT, and just at your beginning of it, and say, you know what, BERT was developed by Google, and here's the people who came up with that. Maybe I'll ask them some questions. And there's a very good chance that if you do, the worst thing that can happen is you don't get a response, but often you'll have people be pretty excited that you're someone who's young and who's interested in that. And the other piece around it is that even when you're just at the early stages of figuring some of these things out and learning about them and seeing how they apply to what you're interested in, you can have a big impact, you know, all the time. There are people who are very young, who are just figuring things out around how some of this stuff works. And one of the things that's an advantage that you have is that when someone has been training for years and years on a topic like this, they have a certain way of thinking about it. And that when you are fresh to the topic, you'll have new ideas and new approaches. And, you know, I don't know, again, Vardhan, for an example, when you mentioned like, I could see this being really handy, you know, applying BERT to cricket could be really interesting. That's the kind of thing that maybe no one has thought of that before. And so you don't necessarily have to know all the details of how you would code that yet, but you have the right questions and you have the right ideas. And so for each of you, I would just very much say, explore and experiment and ask those questions. And it's a wonderful way to find your community of people who have the same passions and interests that you do, and to find some mentors and to mentor others along the way.
You know, Daniel, I think the children are sort of still grappling with BERT. You know, can we also tell them that BERT is what makes Alexa really understand what they are asking? Example, if you ask Alexa, should I wear my coat today? You know, what are you actually asking? That is it cold outside, right?
Right, right. And that's it's fairly sophisticated when you think about it, that that it can be an approach where when you ask that, you know, what should I wear? There's a lot of context there that we as a human can pick up on easily for that. And by training it again and again on texts where people ask a question like that, it might be in a novel, and the person says like, oh, put on a coat, it's cold outside. That's a little bit of information that then is able to help BERT know, well, those things kind of relate to one another. So yeah, that's a great question. One of the, sometimes even just experimenting with the tools themselves help. So give me 1 second, and I'm going to load something else up for us to try, just to give a little bit of an example of how a transformer generally is able to do interesting things. I'm going to stop my share for a sec, and I'm going to start a different share, and we're gonna play for a second. So I want one of you to give me a really short phrase. It can be anything you like.
Yes, sir.
Can I give it?
Yeah.
It can be based on anything of phrase.
Anything at all.
Okay, online school rocks.
Online school
Rocks.
box?
Yes. No, rocks.
Okay.
ROC.
Okay.
Rocks.
Oh, online school rocks. Nice. So what's going to happen in a second when I hit run the model is that it's going to go through its database of all of the texts it's ever seen, and it's going to say, when someone says online school rocks, what should come after that? What would be the next words that should follow from that? So we're going to tell it to do its thing. It's doing that right now, and I'll explain afterwards a little bit about what the sliders are doing and what they mean. But it's now going to try to compose a paragraph that it may be great, it may be totally ridiculous, but that's based off of that. So check it out. So this was just written just now by an artificial intelligence using a transformer. Online school rocks, the future of education. Our schools are now so entrenched in the same old that it is only a matter of time before they become obsolete. So how do we create a new way of teaching and learning that will be as revolutionary as the internet itself? We've already been down this road before. In the 1960s, the government established the National Center for Educational Statistics to gather data on the state of education in the United States. One of the most important pieces of research the center conducted was the National Educational Longitudinal Study. In it, over 12,000 high school seniors were followed for over 10 years. So that sounds like an essay to me. That sounds like somebody is actually beginning to compose a thing around that. It has a fair amount of meaning. And I just think it's super cool that behind that is just analysis of the frequency and of the relationship between words. So the computer doesn't really understand the details of what it's saying there, but it is able to understand that these words hang together really well. So that's,
Excuse me.
yes, please.
I didn't understand what the temperature is and what the EAI model is.
Yeah, fantastic question. So for top P, this is looking at how, if I remember it right, this has to do with how tightly the words are are being connected. So the higher the level of this, and actually one second, it's such a good question that we may want to look that up in a sec. What temperature is, it's kind of like with molecules, where when something is cold, it's static, and when something is hot, it's vibrating. When the temperature is set to nothing for this, every time you run it, it's going to give you the same answer. It's going to use the same formula to figure it out. When you increase the temperature, that tells it to be a little bit more random and take a little bit more chance in terms of how it creates it. So if we run it at a temperature of 0, we'll run the model and see what it says. But if we run it twice, it's going to say exactly the same thing as what it said the first time. So it's a lot more boring sentence. It's simply saying, I've been a fan of schools, online schools, for a long time, and going with that. It's variations on that again and again. If we run it again,
yeah, I understand. Can you put it to full, the temperature?
Absolutely, yeah. So first I'll just demonstrate. So you see it said the same thing. Now, if we put that temperature all the way up and run the model, and you do have the link to this, so later you can also play to your heart's content with this. So now you'll see it's giving a certain phrase there. And you'll notice that it's a little bit more random. So now it's talking about insurance and sales associates and all kinds of things. There's a little bit of gibberish mixed in there. So it's reaching a little bit further and going a little bit more wacky in what it's trying to do. And if we run the model again, something totally different than what it came up with before. So with the temperature,
What's a good temperature and top P to stick with while we're doing this?
could you say that one more time?
So what's a good average temperature and top P to stick with while we're trying it out?
Such a great question. So they will have figured out a pretty good one. So the default they go to is 0.8 and 0.9. So when you load up the page, it will have a good average listed there. And if you're wanting to explore with this specifically, it also has a list of some prompts that are likely to give you interesting answers. So these are some things that people have used already on it that they find are pretty good. Yeah. So do play with that and play with some of the other resources that are there. I see a great question there. EAI, I don't know is my my first answer there. Let's take a look. Oh, you know what it is? It's a Luther. That is the name, I believe, of the group that's putting that together. So it's a specific software package. So EAI is specifically a Luther AI.
So I typed Spider-Man and I put the temperature to 0. All that came is gibberish.
Interesting. But if you hit run again, the same gibberish should pop out if you put the temperature to 0. Probably what that would mean. Well, actually, I want to ask you, what would be your theory around that? Why do you think it's spitting out stuff that doesn't make much sense?
Because the temperature is 0, because it's not told to go that deep. It's just saying whatever comes to your mind. Don't think, just put it. Don't think, just put it in.
Yeah, I think it's not reaching very far. It's saying these are the words that I'm
Papa, look at this.
related.
Excuse me.
Yeah.
I have another question. I understood what temperature is, the randomness and the deepness, but the depth. But what is the top P?
Yeah, let me give you the right answer, and I am going to look that up to make sure that I give you the right answer.
Excuse me, sir.
Yes.
Sir, how should I open this on my screen?
He sent the
sure.
link in the chat. He sent the link in the chat.
I can send it again though. And
Sir,
while I look,
because if I
Prisha, go ahead, Prisha.
Because I opened this, it said that it's warning like this.
Oh, it's giving you a warning when you try to open it?
Yes, sir.
Okay, well, yeah, I would be cautious then, just because I don't know why it's giving that warning. But this is the link that should do it when you're going to it. But again, if it's giving you a warning,
Sir, it's showing you are leaving Zoom meeting. Click proceed to continue to the link below.
I see. Yeah. So because you're using Zoom maybe through the web, it's just letting you know that if you clicked on it right there, it would take you away from the meeting, it sounds like.
So now it's coming, your connection is not private.
Okay. So one of the other things, I just want to answer one final piece of that question around why for Spider-Man did it give gibberish? And the other reason is that even though it's been trained on huge amounts of text, probably only a tiny bit of that text had the word Spider-Man. And so when it comes across that word, it doesn't know what to do with it. It doesn't know how it relates to other words. So the more connections it can build between how that word relates to other words, the more sensible what it tries to say about it will be. Now I'm curious.
So we can't put any words, we only have to put phrases.
You can put single words if you want, but the more you put in a sort of a phrase, the more that gives it something to work with. And the more common the words are, the more likely it is that it's going to have some kind of connections that it can build.
But one question, look, I just tried this again. I put Spider-Man, but this time the temperature was on 1.5. That is the max.
And what did it give you?
It gave me, I feel that something is, a little bit is gibberish is there. But Spider-Man, it said Spider-Man maintained attribute. A people woves coffee ginger to Santa Martha. Okay, that is, okay, it's gibberish and it does not make sense.
But it's better gibberish than the first gibberish we got. But I think it's just because of the fact that that word Spider-Man, it has so few texts to try to understand what it's about.
Yes.
You know, Daniel,
any other questions or ideas that are there for folks? So I want to be aware of your time. I'm loving the conversation, but I don't want to overrun the time too much.
I had a question.
Huh?
Like how do you if you have BERT, like how do you store it in your website? Like how do you do that?
Oh, that's a great question. So say for something like what we were just using, where it's a website where you're able to enter things and then it comes forward. Typically for that, you would have a server so somewhere you have the computer that's actually running all of the calculations from it. And your web form that you put in would be sending the information to the server. The server would be rolling those calculations around and spitting out the output, and that would then go to your website again. So you might use something called Ajax, or you might use something else in order to have it so that it does that two-way communication. Why don't we take one more question, and then we should probably wrap things up there. I'll also say, though, that if there are more questions or things that pop to mind for people around any of what we've talked about, send them to Supriya, and I'm more than happy to answer any other questions that I can or send any links. If there's not any other questions, then what I'll say is just, it's been such a delight meeting you all. It's one of my favorite things to see mind exploring things like this. Yeah, go ahead. One more question.
Yeah, I have a question. So can you put like AI into like a mask, like not like the N95 filter still does give in some germs. So how about can you put in like an AI, like a filter, which is like has an AI mind of its own, and then just filter out all the harmful diseases? And in the mask it feels very, very claustrophobic, and in some N95s they've got that small breathing hole, but even that lets in the germs. So is there a way that you can use the AI so that it only gives in pure air without germs and you don't feel claustrophobic at all?
So I love that question. What a great question to ask. It's asking questions like that is where whole industries or companies or new innovations come from, is people asking questions like that. Of course, my key answer would be, I don't know. I can see some ways that you could try to do something like that. you'd have to figure out, one of the problems would be latency, which means that by the time the mask were able to detect something or other, would it be able to close things off quickly enough that it wouldn't also get to you? Then you'd have to figure out, how is it going to do the detection? What are the inputs going to be that allow the mask to try to make decisions? And then once you figure out what those inputs are going to be, then you'd have to figure out, okay, what kind of AI are we going to be able to use? What's going to be able to be light enough that it can fit on a chip, say, in a mask? Or do we take a different approach? Maybe these masks are using Bluetooth to attach to a bigger system, but then the latency gets even bigger. It'll take it a little bit longer to do things. So you start to get into engineering challenges with that. Yeah, go ahead.
Yeah, so I thought of something else. Yesterday we were watching something called Lost in Space, which is a series which talks about a family which gets lost on another planet. So what if AI could be, so if they use that, their suits and all of their equipment had AI, artificial intelligence, it would help space exploration and really take it to another level. So if we have a suit which just tells us by looking at the position of the sun on which planet we are in the Milky Way or something like that, it would just help to reach other planets. So AI is not only used on the system.
I love it. And again, like, that's the kind of big thinking around how things like this can be used, where if you follow that train of thought and keep asking questions and thinking about where those questions lead you to, I love it when it's something like that, where it's like, I don't know where it will lead you, but it'll lead you somewhere really cool. That's such a neat line of thinking in a really, really cool way. And absolutely, for space exploration and even just astronomy and studying it, artificial intelligence has so many great areas of potential application. And it sounds like you're already thinking of what some of them might be.
Yeah. Thank you so much, Daniel. I'm sorry, I know these kids have so many interesting questions, and I know that today with, the introduction of BERT, to them, you have now planted more seeds where they are going to wonder, you can Google everything. Please ask your parents for permission, have the parental locks on, and ask things. And as Daniel has very kindly offered, if you have burning questions, I have put our email ID on the chat. Send us the questions. Don't be afraid to ask, because every question leads you to another question and you soon get an answer. If the CoronaWhy could be done, across the world with volunteers, maybe you can start a project of your own, for your mask or for space exploration. But thank you so much, Daniel, for being here. Thank you, children, for coming, asking your questions, not being afraid. And
Excuse me, sir.
Yes. Should we take this last one, Daniel, and then wind up? Because I know it's late for you. It's 9:00, kids.
Sir, I have a doubt.
And so was there one more? Was that from Prisha?
No, it's... Rich, ask your question, because then we have to have Daniel sir leave.
Okay. So actually my doubt is like I have a software named Copper Cube game engine. So there I have a big doubt how to upload the sprites and how to do the background. They are not specified like Scratch is specified, like upload background, upload this, and make a drawing of a character, make a drawing of a background. So how can I upload a sprite there?
That's going to be, like Supriya was saying, I think that's going to be one of those places where Google is going to be your good friend, and you're going to be able to actually, in the same way.
Oh, what's up? Excuse me. Hello.
Yes.
Hello.
I'm sorry to interrupt, but we might have to get into another class right now.
Yes.
That's started, but thank you so much. It was a very informative session, and we will keep exploring AI. So yeah, thank you. It was a really awesome, fantastic session.
Excuse me, sir.
Bye. Thank you. Have a good day. Happy Republic Day.
Excuse me, sir.
Kids, Can we say thank you to Daniel sir and wrap up now? Please email us.
Thank you, sir.
Thank you, sir. Thank you.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Bye, sir. Have a good day, sir.
Bye.
Bye, sir.
Thank you, sir.
We can stop the recording, Ishita, now, I think.